Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to create PID control between temperature controller Pt-100 to control the valve by using the PLC S7-200 and software Step 7 MicroWin version 4 page 9 and WinCC Flexible Smart version 3. Okay, so in this section I will create step by step about how to create the PID control between temperature and control valve. Okay, for how to wiring and how to create the scaling, I already show and share in the previous video. So today I will explain about the concept of PID control. Okay, so example, we would like to control the temperature on the room or on the tank. Anything else, we can use this concept. Okay, so today I would like to explain about how to control the temperature inside the tank. It means that inside the water tank, because some process we need to control the water temperature, hot temperature or cold temperature. Okay, so we need to recycle the cold water to cold temperature. Okay, so we can use the concept, and this is an example PID tuning that I already created for simulation, and in this section I will create step by step again. Okay, so let's go. So first I will use the existing project that we already learned in the previous video. Okay, so open the project. Yes, so this is a existing project that we already learned in the previous video. So today I will create one more for PID. Yes, so to create the PID control, first go to tool, go to instruction wizard, and go to select the PID and click next. This is the PID, 8 PID that we can use in this project. So first I will use number 0 of PID loop and then click next. And here is the scaling of PID loop. Example 0 to 100 degrees Celsius, 0 to 10 tons, 0 to 1000 degrees Celsius. So we can set here. Okay, and here is the gain, here is the sample time, integrate time or derivative time. Here is the parameter that we need to use during we tune the PID. Okay, so in this section I will choose 0 to 100 degrees Celsius for temperature controller and then click next. So here is the scaling of analog. Yes, so the PV or process variable we can control from 0 to 32,000. Yes, and for analog scaling we can also start from 0 to 32,000. Okay, and then click next. And here is the setting low alarm, high alarm, or enable analog input module error. So for default we no need to check, and then click next. And here is the address of the PID block. It will start from VB6 to VB125. Yes. So click next. And if we would like to use the manual control output, we can click here. Yeah, check here. Click next and then click finish and click yes to complete the wizard configuration. Okay. So right now we already configuration the PID block. So here we have the parameter. Yes. So to use this block, we go to the main and we can command everything here. Example, create PID control the temperature of water. Okay. And don't forget use the always on. Yes. So SM 0.0. Yes. And then go to the call subordinate. Yes. And then press here, drag and drop the PID to the network. So we will got this block like this. So here is the PID block. So first is PV. So PV it start from 0 to 32,000. Yes. So we can use the input of temperature. So AIW 0. Okay. And the next step we will use the set point, right? We need to set point. Example, set point 20 degrees Celsius, 30 degrees Celsius, 80 degrees Celsius. So we can use this set point. Okay. So we can use the another memory that we want. So example, this is the real. So VD 700 example, but we need to convert from double integer to real first. Otherwise we cannot set point from the HMI. Yes. So I need to copy. Yes, cut here and then paste here first, and I need to convert from double integer to real. Yes. So example VD 700. So this is VD 710. Yes. And for the manual we can also use it. So I can cut from here. Okay. This one for manual set point. So example, it start from VD 800 and VD 810. Yes. This one. And for manual and auto control, we can use another memory. Example M10.4. Yes. and here is the output. For output, actually we can use the analog output from here. Yes, so I will delete this one because we not use it. The previous video we just simulation. Actually we can use AQW 0, yes, directly like this, but I need to show on the HMI, right, for percentage to set point the control valve. So I need to use like this. Example VW 90, yes, and then I will use this one. So move it. Yes, move it. And then I will use move VW 90 to AQW 0. Yes. So this one to HMI and this one to the control valve. Okay. So the actual temperature will show here, and then the analog output to control the control valve will go here. Okay, so let's compile the project. Yes, okay, error 0, so we can save the project and then download to the PLC. Okay, stop the CPU and then download to the PLC. Okay, start the CPU and then online. Okay, so right now the set point is 0 and the actual temperature around 22 degrees Celsius. So we need to create the HMI for set point or for select from the HMI to control the PID, right? So let's go to software Simatic WinCC Flexible 2008 Smart V3. Yes, let's go. Okay, here is the WinCC Flexible Smart version 3. So let's open. And I will use the existing project that we already learned in the previous video. So open the existing project here, Pt-100. And let's go to the text to create the new text, right, for set point and for the push button for PID, right? So here is the existing project that we already learned in the previous video. Yes. So maybe I will delete something first. Set point temperature, right? Maybe I will resize the picture to be good looking. Yes, because in the previous video it's so small. Yes, so I can write feedback from control valve. Okay, feedback from control valve. It is the percent, right? 0 to 100%. Okay, and I will increase the font size a little bit to be 22, yes, or 26, yes, like this. Easy to looking. For unit, maybe I will use this dimension to be the same, yes. So we need to use 4. Okay, just arrange to be like this first. Okay, so the first one is set point the actual temperature, right? Set point the temperature that we want to control, and the second is the feedback temperature, right? So this one I need to delete first, and then copy from here, and then edit. So this one is the actual temperature inside water tank. Temperature of water. Okay, just like this. Temperature of water. Okay, align to be like this. So this one is set point that we want to control, and this is the feedback from the temperature controller, and this is a automatic control set point to the control valve, right? So control valve, right? Set point to, sorry, set point to control valve. It is percent, right? Because it is 0 to 100% also. So this is a feedback from control valve. It is percent also, 0 to 100%. Yes. Okay, like this. And for unit, this is the degree Celsius, and I will copy and paste. It is the degree Celsius also, yes. So we need to create the new text, right, for set point. So first we need to create VD 700, yes, for set point. So let's go to text, and we can write PID, or we can write temperature CTL, yes, temperature control and it is the double word, right? So double word, and start from VD 700, and one more for manual control, right? Temperature manual CTL. It is the double integer, right? Let me check again to confirm. So double integer, sorry, it is double integer. Yes, this one double integer also. Yes, and one more, we need to create the actual set point of control valve, right? So VW90. So go to the text and then go to the auto set point valve. It is the word, right? So VW90. Okay, and go to the screen. So the text that we already created here, we use it. For this one, we don't use anymore, so we can delete. Okay, so we use only file text. The first one, control valve feedback. Control valve feedback, yes. Pt-100 actual. Temperature controller set point. Temperature control, yes. Or we can use like this, easy to understand. So example, PID set point. Yes. This one PID feedback. Yes. And this one, control valve feedback, right? So control valve feedback, that's okay. And this one, temperature control, right? Manual control. And this one for actual. Actual set point, right? Actual set point valve. And one more for manual and auto selection, right? So auto control. Yes. It starts from M10.4, right? So M10.4. It is Boolean. So M10.4. Yes. So we need to create one more button, yes, for select the PID. So example, auto control. Yes, auto control. So when we select this button, we can use the auto control. When we not select, we use the manual control, right? So manual, off is manual control, on is auto control. So we can switch this one, auto control. And for off, it is manual control. Okay, like this. So when we not select, it will manual control, and when we select, it will show auto control. Okay, I will adjust the font size a little bit to be 18. Okay, like this. Okay, so we need to insert the text to here, right? So let's go to the text. Is for set point, right? So go to the set point. So PID set point. And this is the actual temperature, right? So actual temperature, PID feedback, right? This one. And this is a set point. We need to set point action, right? Output. Let simulation after we can set. So this one set point to control one, right? So we can choose the text. Set point to control one. This one, and we need to scale, right? So let's go to this one. And go to edit. Then go to the linear. And we need to use the set point, yes, here. Yes. So we can go to the edit, linear. Okay, so we can edit. Yes. Go to the set point to control valve. Yes, go to this point and then click here. So let's go to linear because it is the PLC. So we can use 0 to 32,000, yes, and 0 to 100%, and click here. And this is a feedback from the control valve, right? So feedback from the control valve. Okay, this one. So we can simulation before download to the HMI. Yes. So this one no need to set point, right? Okay. So we need to set point only this one and this one. And then we need to configure the button. Yes. So go to property and then go to event. Yes, please set bit. So bit point, yes, auto control, and release. We can reset bit auto control also. Yes. So when we press manual mode, we can control from the HMI also. Yes. So we can create one more text for VD800. Yes. It is double integer. So we can go to the text and manual set point. Double integer also, right? And start from VD800. And we can arrange this one. So we can copy this one to here. Okay. So this one manual control. From HMI. And this is the manual control. Yes, this one, right? 800 manual set point. And we need to choose the set point action also. Okay. This one I would like to change a little bit for manual mode. And this one auto mode. Yes. And we can save the project and then download to the HMI. Okay. So before download to the HMI, I will reboot the screen and turn on again. And don't forget freeze the transfer. Okay. Right now I already freeze the transfer. Yes. And then we can go to download. Yeah. Click this button and then download to the HMI. Okay. The data is transferring. Yes. Go to the HMI. And for this take, I will check the actual temperature, right? And this is a feedback. Feedback is actual set point, right? Control one feedback, this one. I will download again, yes, because the text is duplicate. So I will press transfer again. And then download to the HMI again. Okay, so that's all. And then we can control from the HMI. Okay, so right now the analog output show around 0, right? Let me show the actual. So the temperature show around 23, 22 something, yes. And the analog output show 0 milliamp, yes. And if I set point to example 60 degrees Celsius, yes. And then I press the auto mode, yes. And then we need to tune the PID, right? So to tune the PID, M10.4 is turned off, right? Turn on or not? Okay, turn on. So let me change a little bit for the button, right? Okay, change this button to okay, I will delete this one. Okay, and then go to the click. So when the click invert bit, yes, we can use invert bit. So invert bit auto control, yes. And then let me download to HMI again. Okay, press button download. Okay, that's all. And then we will test again. So first I need to press the button auto control and then set point value example 60 20 degrees Celsius. Yes. Let's see the milliamp is start increase. Yes, because the process variable around 22 degrees Celsius. Yes. So we need to tune the PID. To tune the PID, let's go to Tool and then choose the PID Tune control panel. And then we can go to Help. Yes. And we can follow the manual of PID tuning here. Yes, PID tuning. Okay, here around 0.45 for again. Yes, and 0.03 for integrate time. So here we can use another value that we want. Example, I would like to use the gain for 1.5. Yes, it will work fast. Yes, if we set 1.5, let's see the value is up very fast. And I need to check the point on the HMI a little bit because it seems not show the value for here. So here actual, right? Actual set point. It's correct or not? VW90, right? It is correct. It is the output, right? Let's download to the HMI again. Click here and then download. Okay, finish downloading. And we will test again. So here we can tune the PID fast or slow that we want by adjusting the gain or adjust the integrate time. Yes. So right now I will set point again. Example 80 degrees Celsius. Let's see the milliamp is so fast, up so fast. And if we would like to adjust something to faster than here, we can adjust here. Example 3 for gain. So when I have that, it will fast, adjust fast. Yeah, 20 milliamp. It means that 100% to actuator. So here is 32,000, yeah, for analog output. But sometimes if we use the gain is too much, the process is so swing. So we need to adjust to be smooth. Yes, follow the manual operation like this. So I will adjust the temperature here to be so around 22 right now, around 22. Yes, so I will adjust the Pt-100 to be hotter than this one. It start degrees. Yes, around 25 something. 27, 28, 29, 30, 31, 32. I will increase the temperature. Forty-one, 42, yes, increase. 48, yes. Let's see, the output is swing, right? Because right now it control. Let's see, the analog output is swing also. Right now the temperatures show around 60 degrees Celsius and set point 80, yes. And milliamp show around 7 milliamp, yes. So this is just example about how to create the PID control for control the temperature inside the water tank, or if we would like to control some concept to similar here, we can use this one. Okay, so thank you very much for watching my video, and if everyone would like to use this concept, we can follow my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video, and I would like to request all of you to like, share and subscribe my video also, to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.